I'm Justin Eckstein, and I'm a senior computer engineering major.
I'm Greg Miller, and I'm a computer science major.
I'm Derek Holman, and I'm a computer engineer.
And we're the Feather Rufflers.
For our senior design project, we're going to be designing a microcontroller with a GPS component so that we can track the GPS coordinates of pheasants over a low-frequency radio. This is something that's traditionally done manually by ecologists, and we're going to be designing it as a collar device that we can put on the pheasant, and it's going to be battery powered, so it's going to need to be efficient, and it's also going to have to be lightweight. We are limited with a 3% body weight, which leaves us with about 30 grams to work with, which is a relatively small amount. The other thing is, because it needs to be battery powered, it needs to be extremely efficient, and it needs to be able to regenerate energy. And we're planning on using a solar source, possibly a solar cape that can be mounted to the back of the pheasant. So that'll allow it to be regenerative and also long-lasting. One of the last things that we need to be able to implement is a retrieval function, so that when it does near the end of its life, we can go and grab the device by sending a signal and figuring out what its GPS coordinate is at that moment in time.
So this is our third iteration board. Over here is the low frequency antenna. This operates at 433 megahertz. And then over here is the GPS device, and it gives us the feeds over, it gives us the NEMA messages as we listen to it over UART. And up here is the JTAG header, and then over here is where we connect both the battery and the solar panel to the board, and then over here is the on and off switch. Now this board had several problems that we had to discover and figure out, and one of them was this JTAG header, this pin right here that doesn't have a wire sticking out of it. That was supposed to be unconnected, so we simply just had to take it out to avoid running into problems with the programmer. And then another thing was we removed some power circuitry devices trying to get the part count to be lower, and in the process of that we accidentally disconnected two nets that were supposed to be connected together. So once we figured it out, we simply just had to solder a wire from the 2 points to complete the connection, and then after that the device started working again. So that's the third iteration and all the things we've learned from toying with it. Hello. So right now I'm working on trying to fix this board because there's some hardware issues with it. So what we're going to have to do is manually solder in a wire to make a connection between two different nets that are currently unconnected. So we're basically going to be making a connection from one of the pins here to a pin down here. Here's the board with the wire we attached to fix the missing connection problem that we had. And now we're going to hook it up to this power source to see if the nets that we were looking for earlier now have a voltage, because they should. Power supply over here has a voltage of 3.3, and I think you could see that. And the multimeter over here is going to give us the voltage, and this pin should now be at 3. If I could make the connection, and it is at 3.267 like we want. Hello. So now we're here to test one of our boards. We already did the fix to fix the unconnected power net, and now we're going to hook up the UART. We're going to connect to the UART with the USB bulb. We already have the power and the JTAG hooked up, so now we just need to make this test program, which all it does is print hello count and this value of this integer, which it keeps incrementing. So we program it. Still programming. And then we run this. We connect to the UART. We connect to the bulb over UART, and as you can see, the hello count is being sent from our device. So the device works. And that's our demo.
Then we zoom in on the Pheasant.
Hello. So it's Justin and I, and we currently have our device set up, running, and it is now with the GPS receiver right here, and we have the device running, and as you can see now, it's actually pulling current because the GPS requires a lot more current than the MCU. And it's running a simple program where it's receiving the GPS fixes from the GPS over UART, and the MCU is then relaying the messages over a different UART, which we are listening to via this USB bulb. So when we look at the computer over here, you can see all the GPS messages. And because we are inside, we literally cannot see any satellites. But when we go outside, that would change. So this is pretty much the end of this video. Doesn't.
Alright, so some future work for our current project. We want to finish the wireless drivers, also test and debug our current drivers, some solar panel field testing on our current device, and also get our enclosure prototype working.
Bum 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 bum.